Hey, here's what we're looking at today. Today we're looking at factoring trinomials with leading degree 2. Wait, didn't we do that yesterday? No, except for now our coefficient of the x squared term, or a value here, is going to be bigger than 1. Now yesterday we were able to see where sometimes we can factor that leading coefficient out, and we should always try to do that, but sometimes you can't factor the whole thing out. Sometimes your a value, even once you've GC'd is still bigger than 1. And sometimes you can't GCF. So the first thing you want to do is try to take out a greatest common factor. If you can, it's totally worth it because the rest of your calculations are going to be much smaller, and it's easier to just put in that little bit of work at the start and then use smaller numbers the rest of the time. It's well worth that. So once you take a GCF out, if a equals 1, now you can use that really easy method. If a is still bigger than 1, we have to use this method below, which is not impossible. It's more work though. It's worth trying to factor out as much as you can. So here's the new method if a is still bigger than 1. Take your new a and your new c value and multiply them together. So I have an example over here. So we're going to take 4 and negative 6 and multiply them together, and we get negative 24. So that a times c, that product, goes on the top of your diamond. Just like before, your b value goes on the bottom. So now we're going to solve the diamond. And here, numbers that multiply to negative 24 and add to positive 5 are going to be 8 and negative 3. Now we're going to put our answers to the diamond in the middle of the polynomial in place of b. So here was our original polynomial. We're going to rewrite that, except for in place of 5x, we're going to write 8x and negative 3x. Yeah, whatever that variable is that was with the b right here, in this case it's an x, we have to place an x with that. Just like that. That's a little bit different than last time. Last time we were close to having the finished product. Now we're actually kind of expanding and making it look a little more complicated going from here to there. However, now notice that there's 4 terms. No, not all of them are, there are 2 of them you can actually combine. We're going to kind of uncombine them here, unpack it, expand it. And so now we have 4 terms. We can do some factor by grouping. Notice this third term is negative, so we're going to emphasize that it's negative and then try to carve, whoa boy, carve that out. So take the GCF out of these first 2 terms. Now you can factor out a 4x, and that leads x plus 2 in the parentheses. Remember, when we factor by grouping, when we have 4 terms, and we partner the first 2 and the last 2, what's left in the parentheses we want to have be exactly the same. So 3 does go into negative 3 and negative 6, but we want what's left to both be positive. So we need to factor out a negative 3, and then when you divide both of these by a negative, you get a positive result. Hey, now our 2 parentheses are binomials matched, so you bring one of them down and take your GCFs and put them out in front together in parentheses. That is the factored form, and it truly works, folks. If you went back and foiled this together, now you would get 4x squared minus 8x minus 3x. Mr. P made a mistake. He'll come back to it in a second. And negative 6. Did you catch the mistake? 4x times positive 2 is positive 8x. So this looks like that, which is good, but then to really combine like terms, it is equivalent to that thing up there. So we do get 4x squared plus 5x minus 6. Boom. This is the true equivalent factored form of this polynomial in standard form. We have factored. factored that polynomial. Let's see if we can use this process to try to help us out with this. So look for a GCF in this example right here. I can't factor a number or a variable out. So now we're going to multiply our A and our C together. So we get 2 times 5, which is 10. So you actually don't have to write the 2 times 5 down, but that's where it's coming from. And on the bottom we get 11. So what two numbers multiply to 10 that add to 11? 1 and 10. So here's the maybe sometimes the most confusing part to students. Now we take those answers in our diamond and we put x's with them, or whatever our variable is, and instead of writing 11x, we write down 1x plus 10x, or vice versa. Now we bring down our leading term, so in this case 2x squared, and our constant, our c value, plus 5. Now we have 4 terms. Realize, folks, if we did combine like terms right here, we would get, whoa, misfire, we would get 11x. But when we unpack it this beautiful, magical way, we can now factor by grouping, and it will work out. So out of the first 2 terms, we can factor out an x, so we get 2x plus 1. And out of the second 2 terms, we can factor out a 5. When we factor out 5, we get 2x plus 1. Whew. That's good they match. Put your GCFs together, we get x plus 5, and then bring down one of your matching binomials. 2x plus 1. Bada bing, bada boom. And again, if you foiled that together or multiplied it back together, you would get this thing once you combine like terms. Let's try that one more time. It's pretty fun. Here's our next example. Look for a GCF. Don't see one. Now take your A and C and multiply them together. You get negative 21. We want numbers that add to negative 4. So negative 7 and 3 work. Don't worry if you're not that fast. Mr. Pilo's doing diamond problems. He's pretty solid at them. But hopefully you do agree, or after some time you find that that is the right combination. So solve the diamond. Now put your answers to the diamond in the middle of the polynomial in place of b. So instead of this bx, we're going to have negative 7x plus 3x, which does combine to negative 4x. It's equivalent, but this allows us to factor by using grouping. Drop down your 3x squared. So now this negative 7x is actually like a minus sign. And at the end, we need to bring down this last term. So that's minus 7. So now we have 4 terms, so we hug the first 2, hug the last 2, factor out an x out of the first term, x, 3x minus 7. Out of this last term, these last 2 terms, I don't think there's any we can factor out. This doesn't have an x, and there's no number that multiplies it into or is a factor, is a factor of 3 and 7. So we're going to factor a 1 out, which usually we don't even write down, but in factor by grouping, out of these first 2 pair, or out of the first binomial or the second binomial, if you can't factor out anything, you do want to put a 1 there, because now we put these together. It's x plus 1. That 1 is really critical. And then, Mr. P forgot to bring that 3 down, right? Because I just factored out a 1, so that doesn't actually change either of these terms. So the matching binomials do in fact match. We have 3x minus 7. And again, if you multiplied these 2 binomials together, you would get the polynomial up top once you combine the x terms. There it is. That's it. I'm gonna in a second do a few from your assignment. You're welcome to do those with me.